Hello everyone, welcome to Interview Question Talk. Today we are talking about how transactional annotation works in Spring. First, what is transactional annotation? In Spring, the transactional annotation is used to manage transactional declaratively, meaning Spring will automatically handle the starting, committing, and rolling back of database transactions for you based on the configuration you provide. So, how does transactional annotation work in Spring? First, defining a transaction. The transactional annotation is applied to methods or classes in a surface layer or any other layer to define the boundaries of a transaction. When you apply transactional, Spring will manage the transaction life cycle, open the transaction before the method starts the commit and committing or rolling it back after the method finishes. And based on the configuration, it will help to manage the transaction propagation. Spring allows you to define how transactions behave when they interact with other transactions. This is done using the propagation attitude. The most common propagation behavior is required, which means that if a transaction exists, the method will run within the transaction. If not, transaction exists, Spring will create a new one. And also the transaction isolation level will control by the isolation attribute of this annotation. The isolation level controls how transactions are isolated from each other. For example, it defines how the data read by one transaction can be impacted by other concurrent transactions. And this actually is mapping to the database transaction isolation level, and Spring not do a lot of things with it. It just transfer it to the database, and you can set the different isolation level for each in transaction. And with these two parameters, you can control the rollback behavior. By default, Spring rollbacks rolls for the transaction when a runtime exception occurs and commits when the method finishes successfully. But you can define which exception the transaction will roll back, and know which exception not trigger the rollback. And there is a very important mechanism in here is transactional proxy, which Spring uses proxy to manage transactions. When an transactional annotation is applied to a method, Spring creates a proxy for that method. This proxy is responsible for managing the transaction before and after the method execution. The proxy ensures that the method runs within the scope of a transaction, committing and the transaction if everything goes fine, or rolling it back if an exception occurs. An important thing here is that the transactional annotation only works on public methods because proxy in Spring work only with public method. Also, if you code directly within the same class, because the transaction proxy wouldn't be invoked, so this annotation won't be active. So that will cause the other method will not control in a transaction. And based on all the preparation that finally we got to this method execution step. When a method annotated with at transactional is executed, the following steps will occur. First, transaction begins. Spring starts a new transaction or joins an existing one, depending on the propagation setting. And then method execution. The method's business logic is executed. Finally, transaction commit. If the method executes successful, with no exceptions, Spring commits the transaction. And if a runtime exception or a specific checked exception is thrown, Spring rolls back the transaction to maintain data consistency. And from this whole working process, you can see that compared to a traditional transaction handle approach, there's nothing different with your code and handle the transaction manually. But with the Spring feature AOP, you can centralize repetitive code which open the transaction, commit the transaction, and roll back the transaction, and even control the transaction with related configuration patterns. So actually, this is the way to use AOP to implement the transaction manager solution. Alright, thank you for watching. See you next time.